that was oxidation only.
Was the oxidation reactions.
Yes, sir.
So we are discussing actually the redox reaction, na? Indirectly we can say.
Yes, sir.
What is redox reaction? What is redox reactions? Have you written the definition? Check it in
No,
your
sir.
copy. Not written.
Sir, not it.
What is combination reaction? Check in your
Sir,
copy.
sir, it is a reaction in which two or more elements combine together to form a
Single product. Okay.
single.
Okay. Tell me that AgCl is an example of decomposition of AgCl. This reaction is used in which kind of AgCl? Decomposition to give Ag plus Cl2. It is an example of combination reaction. No, it is not an example of combination reaction. Okay, let's start. Note down the topic. Decomposition reactions. Note it down. The reaction in which a single compounds break to decompose to form two or more simpler compounds or elements. Okay, note it down. The decomposition reaction, the reaction in which a single compound breaks. The reaction in which a single compound break to decompose two or more simpler compounds or element is called decomposition reaction. Note it down. When you're done, please let me know.
Okay, sir.
Done? Done up to here? Done?
Yes, sir.
Okay, so if I'm saying here that if we have let A compound, it decompose like it is taking heat energy or some energy or electrical energy, it may be. Okay, any form of energy if it is taking and it is decomposing to form more than two or three products, more than two products, okay, like B plus C plus D and so on. It is known as decomposition reaction. It is known as decomposition reaction. Okay, got it?
Yes, sir.
Got it? So, for example, if we have the reaction in which a single compound break to decompose two or more simpler compounds or element is known as decomposition reaction. For example, if you take PbNO3, heating of PbNO3 when lead nitrate is heated, PbNO3. Okay, if I'm saying PbNO3, NO3 whole twice, when you heat it, okay, it will decompose to PbO plus NO2 plus O2. Okay, so we will say that this is a single compound or reactant, or it is a reactant and it is decomposing into more than one product. Okay, more than one product. or substance. Okay, so we'll say that this is a decomposition reaction because it is a single compound. The term condition that here must be single. And this, sometimes the question comes for this NO2. This NO2 is actually, if I'm saying that this NO2 is actually a gas, okay, and which has brown color, brown fumes. So if the question comes that when lead nitrate is heated, it gives brown color fumes. The brown color fumes is due to, so we will note down that brown color fumes is due to the nitrogen dioxide. Okay, understood? Yes or no? Harshit, you understood?
Yes, sir.
Okay, so please note it down.
Sir, could you repeat that brown fumes is formed due to
NO2, nitrogen
NO?
dioxide.
Oh,
Nitrogen dioxide.
done, sir.
Done? Okay. Similarly, if you heat the ferrous sulfate is green in color. Okay, this is due to the presence of crystal inside it. These green color crystals are known as ferrous sulfate crystals, and these are green in color. Okay, so if I'm talking about this one, that this is the ferrous sulfate, that is FeSO4, which is green in color. Okay, when you heat it, first of all, this there you will see that there are some compounds which are going to have formula, and they are going to have water molecule attached to it, like this copper sulfate, CuSO4 dot 5H2. Okay, dot 5H2 dot 5H2 5H2. Okay, like similarly, if you are having instead of copper sulfate, uh, like you are having FeSO4. So FeSO4 has 7H2 water. Okay, and like for example, you are having sodium carbonate Na2CO3, it is having 10H2. Calcium sulfate, it is having 2H2. Okay, so this loosely, this is known as when water is attached with dot. Okay, this is known as loosely attached water molecule. We called it loosely, okay, loosely attached water called called water of crystalline, called water of crystalline. Okay, what we called it? Water of crystalline. Okay, understood? Yes or no?
Yes, sir.
Understood? So when you heat it, like for example, if you heat it copper sulfate dot 5H2, it first changes to, first loses water of crystalline. Will lose of its water of crystalline. This is blue in color, blue in color. Due to this water of crystalline, this is blue in color, and this is white in color. This is white in color. Similarly, when you heat FeSO4, ferrous sulfate dot 7H2O, it is green in color. Green in color, it will change to FeSO4 plus 7H2. Okay, understood? Understood?
Yes, sir.
So this color is green, its color is green, and this color is transparent. Transparent. Okay. So if I decompose the ferrous sulfate, FeSO4 dot 7H2, so it changes its color to FeSO4, and this water of crystalline will be evaporated. But when you further keep on heating this one, it will change to Fe2O3, plus sulfur dioxide plus sulfur trioxide. And this sulfur trioxide has a pungent smell. Pungent smell. It is known as a pungent smell, means rotten, like, or rotten egg smell. Rotten egg smell. Okay. And this Fe2O3 is going to have brown color. Brown color. Okay, so if I heat the ferrous sulfate, its color first changes from green to colorless, and then to brown. Okay, then to brown. So FeSO4 first changes from FeSO4 to only FeSO4, and you further heat it, it will change to Fe2O3. This color is green. This color is transparent, and this color is brown. Note it down.
Done, sir.
Noted, everybody?
Yes, sir.
If the question comes in examination, then pungent smell is due to, tell me, pungent smell is due to
SO2.
sulfur dioxide. Okay. What is water of crystalline? Loosely attached water molecule per unit formula of the compound. Note the definition of water of crystalline. Loosely attached water molecule per unit formula of the compound. Loosely attached water molecule, water of crystalline. Water of crystalline. It is loosely attached water molecule per unit formula of the compound. Per unit formula of the compound. Done?
Yes, sir.
Similarly, AgCl. AgCl means silver chloride. When heated, it gives you Ag plus Cl2. And similarly, AgBr in the presence of sunlight will gives you Ag plus Br2. Okay. So note down this reaction. And this reaction is known as photo decomposition reaction. Photo decomposition because it is done in the presence of sunlight. Okay. and it is used in black and white photography. The question comes that which of the following reactions is used in black and white photography? Then you need to mention these terms. Okay. Got it?
Yes, sir.
Put it down. Done? Okay. Now moving to the next part here is that if you do the electrolysis of water, if you are doing the electrolysis of water, okay, then in that case, if you are having H2 plus O2 will gives you H2O. Okay. So this is water. Here it is two water molecules. When you balance it, no. This is the normal reaction. This is a combination reaction. But when you pass electricity to it, to the water, then it will give you H2 plus O2 back. Okay. Got it? And here the ratio of the hydrogen gas to the oxygen gas is 1 is to 2 is to 1. The ratio of gas during electrolysis of water, during, note it down, during electrolysis of water, okay, it is hydrogen to oxygen gas. Oxygen is 2 is to 1, and it is the ratio of volume. Ratio of volume. And if I ask you the ratio of mass, the ratio of mass is 1 is to 8. 1 is to 8. Note it down. And since these reactions occurs in the presence of electricity, so it is known as electrical decomposition reaction. Electrolysis means breakdown, or electro decomposition reaction. Electro decomposition reaction. Note it down. You done? Gianna, Harshit, Nabila, you done?
Yes, sir.
The ratio of the volume of hydrogen is to oxygen is 2:1, and that of mass is 1:8. Okay. The next type of reaction is the combination reactions. Okay. Combination is the opposite, exactly opposite to this decomposition reaction. In this, more than one substance will be there, and they are just going to give you a single product. Single product. There will be a single product. More than one reactant. There must be more than one reactant. More than one reactant are there. Okay. So do this one. The reaction in which two or more element or compound chemically combine together to form a single product is known as decomposition reaction. Sorry, combination reactions. Note it down. Note it down. The definition.
Sir, we have to do a combination reaction.
Yes.
Okay.
Note it down. Done.
Yes, sir.
So if I'm looking here that, for example, C plus O2 will gives you CO2, H2 plus O2 will gives you H2, N2 plus 3H2 will gives you NH3, CO plus water will gives you calcium hydroxide. Okay. N2 plus O2 will gives you N2. Okay. In case of nitrogen, in case of generally all combination reaction are exothermic in nature. Generally, they are exothermic, like you see here. But in case of nitrogen, the bond is broken because nitrogen has 3 bonds. Okay. So the large amount of energy is being required to break this bond of nitrogen atoms. Okay. What happened actually in the chemical reactions? Like for example, N2 plus H2 will give you NH3. Okay. So these two nitrogen bonds between the two nitrogen atoms, they are broken. And the 3 hydrogen molecules, their bonds are broken. And they are forming the 2 new NH3. Two NH3. Okay, they are broken. So always when the bond is broken, the energy is supplied. Energy is supplied. Energy is supplied. Okay. And when new bonds are formed, energy is released. Energy is released. Energy is released. Okay. So you need to keep in mind one thing, that during, if in a reaction, the energy given to break the bond means energy given to break the bond is more than the energy released. Okay. During the formation of new bonds. During the formation of new bonds. So we will simply say that this is an exothermic reaction. Means more energy is given. More and more energy is given. Then the energy leaves. So this is an endothermic. More energy is given. Like for example, in a reaction, okay, you give 2000 joule energy and the release energy is only 500 joule. So give 2000, release is 5. So we'll say that you are in a loss of 1500. Means you give more energy. So this type of reaction is known as endothermic reaction. So in case of nitrogen, why the energy given or nitrogen do not readily react because nitrogen is triple bonded, and large amount of energy is being required to break this bond. Nitrogen is triple bonded and large amount of energy is required to break this bond. You understood?
Yes, sir.
So that's why in case of nitrogen, in others cases, give me a minute. Okay, so if I'm saying here that in case of nitrogen, when it is reacting, we'll simply say that the more energy will be given. Okay, more energy will be given. Got it? So note it down. That energy supplied means we'll simply say that in case of nitrogen, it is an endothermic reaction. In case of other, it is exo. Exo means exothermic, endo means endothermic. Okay, so note it down and write there whether it is exothermic or endothermic. Note it down, please. Done? Yes or no? Yes or no? You are not participating in the class.
So yes, sir, done.
So these are the example of combination reaction. Okay. The next type of reaction is redox reaction. Next type of reaction is redox reaction. What is redox reaction? The reaction in which there is simultaneously, if I'm talking about what is redox reaction, the reaction in which there is simultaneously exchange of ions takes place. Sorry, not exchange of ions is a displacement, double displacement. The reaction in which simultaneously oxidation as well as reduction is going to take place. Means there must be oxidation as well as reduction. What is oxidation? What is reduction? We're going to talk about it later. Okay. So this one is the reaction in which there is simultaneously oxidation reduction take place. This is called redox reaction. What we called it? Redox reaction. Okay. Got it?
Okay, sir.
Note it down. Redox reaction definition. Everybody.
Okay, sir. So should we write down oxidation as well?
Yeah, note down the definition of this one also.
Okay, sir.
Note down the definition, then I'm going to explain you.
Done, sir.
So let me explain you what is redox reaction. Arshit, are you there?
Yes.
From the next class, keep in mind that I will not allow any students who is not going to turn his or her camera. Okay, so every student is going to prepare yourself such that you can able to turn on your camera. Okay, because there must be eye to eye contact whether the students are writing properly, maintaining their copy or not. Okay, if you are hiding yourself behind camera and not turning on your camera, then it means that you are doing something wrong. Okay. So let's move further here. This is the oxidation reaction if I'm talking. Or addition of oxygen or removal of hydrogen. Okay. Addition of oxygen or removal of hydrogen or increase in oxidation state. Means for example, in a compound, if we are adding the hydrogens, like for example, C plus O2 will gives you CO2. Okay. So here you see that in carbon, oxygen is being added. So we say that carbon is oxidized. There is an oxidation of carbon is going to take place. Okay. Similarly, if I take NH3 ammonia, when you heat it, it will gives you N2 plus H2. Okay. Okay. So you see that in ammonia there is hydrogen, but you see that the hydrogen has been removed from it. The hydrogen has been removed from it. Okay. The hydrogen has been removed. So we'll say that ammonia is oxidized. Oxidation of ammonia is going to take place. Okay. Oxidation of ammonia is going to take place. Note it down. So what is oxidation? The addition of oxygen or removal of hydrogen or increase in oxidation state. Increase in oxidation state is called oxidation. Means if oxygen is being added, then carbon is oxidized. We'll say that carbon is oxidized. Okay. Here, similarly, from ammonia, nitrogen is being removed. Hydrogen is being removed. So it means ammonia is also oxidized. Ammonia is also oxidized. Okay, got it? Got it?
Yes,
Yes.
sir.
Next, similarly, reduction. Note the reduction. Reduction is opposite. In the previous one, oxygen was added. In this one, oxygen will be removed. In the previous one, hydrogen in oxidation, hydrogen was removed. Here, the hydrogen is added. So in the reduction, it is opposite. Addition of hydrogen, here it is removal of hydrogen. Okay. Here it is addition of oxygen, here it is removal of oxygen. Here it is increase in oxidation state. We'll discuss what is increase and decrease in oxidation state. It will be decrease in oxidation state. Okay, note it down.
Done.
Done.
Yes, sir.
So if we take the example of like for example, if I'm taking PBO, okay, when you add carbon to it, it will give you Pb plus CO2. You check here, this one is the process which is through which Pb is going, and this one is the process through which carbon is going. Okay, Gianna, you there? Are you getting my point? What I'm saying?
Yes, sir.
Okay, so here you will notice that P from PBO to PB, what is happening?
Oxygen is
Removed. Oxygen
yes
is
from
removed. The removal of oxygen is reduction. So we'll say that lead oxide is reduced. Lead oxide is reduced. Okay, and here you see in the carbon is getting oxidized. Carbon is oxidized. Carbon is oxidized. Okay, next. Done. Carbon is oxidized. Sometimes it will ask you lead. Tell me about the lead. Lead is oxidized or reduced? Lead. So it is
Reduce.
not. It is not lead. It is not lead. It is lead oxide. So when it asks you lead, so lead is here. Okay, and you have to check it to this way. So lead is oxidized. Oxidized. Okay, lead is oxidized because lead is here. This is lead oxide. This is lead oxide, not lead. Carbon dioxide. If it asks you carbon dioxide is oxidized or reduced?
Oxidized.
It is reduced. Carbon is oxidized. Carbon is oxidized. From here to here, carbon is getting oxygen. So carbon is oxidized. Okay, but opposite to this one will be reduced. Carbon dioxide is
Reduce.
reduced. Okay. So it is simple that if from A to B is oxidation. Okay, so then from B to A will be reduction. Got it? You understood?
Yes.
And the substance that is oxidized is known as reducing agent. The substance that is oxidized is known as reducing agent. Put it down. Put the reaction, write each and everything. Lead is oxidized, carbon dioxide is reduced. Put it down. Just wait a minute, let me update the topic. Give me a second. Let's move further. So if I'm having this reaction, let note down this reaction. MnCl2, sorry, MnO2, MnO2, when react with HCl, it will gives you MnCl2 plus chlorine gas plus water. Okay, tell me MnO2. Don't check to water. Okay, don't check this one to water. We don't check. Let me look at this. We never check to water. Okay, we never
Sir,
check
the screen
to
is not
water.
changed.
Okay,
It's
we
still
never
in
check to water.
PDO.
Is it visible to you now?
Okay, yeah.
Okay, now MnO2, we will check Mn2 this way. Okay, we'll check HCl to Cl, not water. Water is not never used to check. Okay, you will not check that hydrogen here the oxygen is added. No, we will never check with the water. We'll check other element. Okay, so here tell me MnO2 is oxidized or reduced?
Reduced.
It is reduced
Reduced.
because removal of oxygen is taking place now. So MnO2 is reduced. Okay. Okay. And HCl, hydrochloric acid, is oxidized or reduced?
Sir, oxidized.
Oxidized. Why? Because hydrogen is being removed now. Hydrogen is being removed. So it is oxidized because hydrogen is removed. Hydrogen is removed. Is removed. Okay. And this one, if I ask you which one is the oxidizing agent? Oxidizing agent. Which one is the oxidizing agent? Tell me, which one is the oxidizing agent?
Cl.
Hmm? Which one
Cl.
is the oxidizing? Cl. No, we will always check it from here. Oxidizing agent means the one which is reduced is known as oxidizing agent. So this MnO2 is reduced. So it is an
Yes.
oxidizing agent. MnO2 is oxidizing agent. Okay. Agent, you know now what is agent? Agent means that is going to help. For example, I am an agent of this one. So means I do this work. So if I'm saying that I am an oxidizing agent, means I am bringing the oxidation of someone. Okay. So MnO2 will give its oxygen. Okay, if MnO2 will not give its oxygen, will the hydrogen will able to will the chlorine will be able to remove this one? No. So we'll say that the substance which is, like for example, in this one, PBO. Okay, take the example PBO. PBO is an oxidizing agent. Why? It is itself reduced because you know that it is itself reduced. PBO, in PBO oxygen is being removed, but it is acting as an oxidizing agent, because if PBO will not give its oxygen to carbon, will it get oxidized? No. So PBO is donating its oxygen to carbon and bringing the oxidation of carbon. So that's why it is known as oxidizing agent. So we, in simple words, we will say the substance that is oxidized is known as reducing agent, and the substance that is reduced is known as oxidizing agent. Okay, got it? Got it? Yes or no?
Yes, sir.
Yes. Okay. Put it down. MnO2 is an oxidizing agent and reducing agent. Substance that is oxidized, so HCl is oxidized. Okay. And here it is reduction, reduce. So it is an reducing agent. HCl is an reducing. Okay. Tell me, chlorine is Cl2 is oxidized or reduced? Cl2.
Oxidized.
No. HCl is oxidized, na? If we are going from A to B, if there is oxidation, then B to A will be reduction. So it is reduced. I'm talking about Cl2. In Cl2, you check Cl2, hydrogen is added. Check it in the backward. Okay, Harshit, understood?
Yes, sir. Now you said Cl. Okay, sir.
Now MnCl2 is oxidized or reduced? MnCl2 is oxidized or reduced? Hmm? Check it, check it. If from A to B is reduced, so this will be oxidized. You can check Mn is added with oxygen. So it is oxidized. Yeah, oxidation will going to take place. Okay, oxidized. Got it? Yes or no?
Yes, sir.
Yes, sir.
One thing you need to note down, this is very important. Here, student, that oxidizing and reducing agent is always chosen from the reactant only. The oxidizing and reducing agent is not found in the product. Like you can check here in the product, we are able to take able to see that which substance is oxidized and reduced. Like Cl2 is reduced. Okay, MnCl2 is oxidized. It is in the product. But oxidizing and reducing agent is always chosen from this side. Note it down. Oxidizing and reducing agent always lies in the product. Sorry, in the reactant. Oxidizing and reducing agent. And reducing agent is always found on the reactant side. Put it down.
Done, sir.
Done, everyone? Yes or no?
Yes.
Done?
Yes.
So this is going to come in examination. Okay. If I'm having copper sulfate plus zinc will give you ZnSO4 plus Cu. Which one is the oxidizing and reducing? Which substance is oxidized and reduced?
Sir, SO4 I think is reduced.
SO4 is reduced. So you say that from copper sulfate, whole we will always take. Copper sulfate, you see the oxygen is being removed. SO4 is containing the oxygen and it is being removed. Okay.
Yes.
So we'll say that it is reduced. Okay. And you so zinc is added with sulfate ion, which is having the oxygen. Okay. So it is oxidation. Okay. Got it?
Yes, sir.
If I ask you copper is oxidized or reduced? Copper. Only copper, not copper sulfate.
Yes.
It is
Oxidized.
oxidized. We will take it in the reverse direction. Okay. Zinc is oxidized or reduced? Only zinc. Zinc is oxidized or reduced?
Zinc is oxidized.
Oxidized. Zinc sulfate is reduced or oxidized? Zinc sulfate.
It's reduced.
It is reduced. Which is the oxidizing agent? Oxidizing agent.
Copper sulfate.
Yes. Always oxygen containing substance is known as oxidizing agent. Okay. The one which is carrying oxygen, it is known as oxidizing agent because it will donate the oxygen to bring the oxidation of someone. So it is carrying the oxygen. Okay. So it is copper. Or you can check it is reduced. So it is a oxidizing agent. Oxidizing agent. Okay. And this one is the reducing agent. Got it?
Yes, sir.
Got it? So that's all for today. We'll meet you in the next class. Thanks for coming. Everybody. Okay. Note it down. Then you can leave. And there might be some is means I think they have. Is there any topic of yours that is left till yet that you have not studied? Let me check. Just a minute. I'm coming back in a minute. Okay. Don't leave, please. Okay. Just wait for 1 or 2 minutes. Yes, dear students, you can leave. Okay. You can leave.
Okay, sir. Thank you. Have a nice day. Bye.
Okay. Take care, everybody. Gianna, are you there? Okay, Gianna, sorry, Galvin and let's wait for other students to join. Okay, Maha and Galvin, you need to wait for 1 or 2 or 3 minutes so that the other student may also join. Okay.
Yes, sir.